So our Spark examples so far have been pretty straightforward, finding the average ratings for each movie. And, honestly, we could have done that probably just as efficiently using Pig or even Hive, right? Because both of those can run on TES, which gives you all the advantages of a directed acyclic graph. Really probably about as good of a tool as anything. So let's do a little more complicated example here that actually drives home the power of Spark. What we're going to do is actually use the Movie Lens dataset to recommend movies for a given user. So what we're going to do is actually look at the entire 100,000 ratings dataset and use that to actually predict the rating for every movie for a given user based on the other stuff they watch. So just like when you go into Netflix or something, it shows you recommendations for movies you might like, or maybe if you go to Amazon and you see things like recommended products for you, same idea here. And what we're going to do is use something called MLLib, the machine learning library that's part of Spark, built on top of Spark Core, and it contains something called ALS, which is a recommendations algorithm. I don't really want to get into the details of how that works, but it is the basic idea behind the winner of the Netflix prize several years ago, where they offered $1 million prize to anyone who could actually produce better movie recommendations than they had already. And ALS is one part of how that was done. So let's see just how simple it is to use something like MLLib to do a very complicated thing using Spark. Now, I mean, if you were try to implement ALS recommendations just using MapReduce, forget it. Like, that would be incredibly hard, right? How would you actually boil that problem down to mappers and reducers? It can be done, obviously, but with MLLib, it just becomes a whole lot easier, and that opens up a whole lot more possibilities to you as a developer. So what we're going to do this in the Spark 2 style again, using Spark sessions. We're going to import from ml.recommendation the ALS package. And again, we'll have row and something called lit that just lets us put a constant value in those rows. Same as before, we're going to load up our dictionary that maps movie IDs to movie names so we can print those out when we're done. And let's again skip ahead here. We're going to create a Spark session just like we did in our previous example. We're going to call this app Movie Recs. And we are going to load up our dictionary that converts movie IDs to movie names. We will then load up the raw data. And this time, notice that we're doing it a little bit differently than before. We're actually using spark.read.text directly on the Spark session as opposed to using the underlying Spark context. But we're loading the same input data file, u.data from HDFS. And this actually returns a data frame, but we want an RDD. So we're going to call .rdd to get the RDD into lines. Now from that, just like before, we can convert that into row objects of our choosing, and we have a parse input function that does just that. What we're doing this time is returning rows that contain the user ID, the movie ID, and the rating. So since we care about making recommendations for specific users, we do actually want to keep the user ID along for the ride this time. Okay, so at this point we have a ratings RDD that contains row objects that contain user IDs, movie IDs, and ratings for each individual rating. We can then convert that to a data frame like we did before, and we're going to call cache on that because I'm actually going to use that data frame more than once. So by calling cache, I can make sure that Spark doesn't do something stupid like try to recreate that more than once. So we now have our ratings data frame that contains rows of user IDs, movie IDs, and ratings. So now what? So ALS, sort of a machine learning concept in general, is the concept of train test. So the idea is that you build a model that makes predictions on your data, and you train that model using some set of input data where it has a known result. In this case, we know the ratings that each user gave for each individual movie. And once we build a model based on that training data, which is our entire Movie Lens data set, we can then test that model by giving it user IDs of people that we don't necessarily know the predictions for a given movie rating, and use that model to predict ratings for movies that maybe a user never even watched. Okay, so that's the basic idea here. Now to do that, I don't want to get into the deep meaning of all these different parameters in the ALS algorithm, but the point is you can do fancy stuff like this with just a few lines of code. So we're going to build an ALS model, okay, using these parameters, and it's going to say that I'm going to feed it a data frame that contains a user ID column, a movie ID column, and a rating column, and those correspond to user identifiers, item identifiers, and ratings. ALS knows what those concepts are. And then I can just call fit on that model with that ratings data frame. So this is basically saying, train my recommendation model on the entire movie lens dataset and give me that model back. And I can now use that model to predict movie ratings for a given user. Now, what I've done here is I've actually fabricated a new user so I can sort of have a persona that I know about. So what I've done is I've gone and edited the u.data file, and I've added 3 rows at the beginning for user ID 0, which didn't exist before. So user ID 0, if I remember right, gave a 5-star rating to Star Wars and The Empire Strikes Back, but a 1-star rating to Gone with the Wind. And you can look up those movie IDs if you want to. That's what those mean. So what we've done here is create a persona of someone who really loves science fiction, but really hates historical dramas. Okay? Reminds me of someone I know. But anyway, that's all we know about this person. So just given those 3 ratings, we're going to ask the ALS model to predict that user's ratings for every other movie. Okay? So first we're going to print out what those ratings are just to make sure that we read them in properly. So we're going to print out ratings for user ID 0. We can then call filter on the ratings data frame to just filter out any given expression. So remember, our user ID column was named user ID, and we can just pass the expression user ID equals 0 to only filter through ratings for user ID 0. And that should come back in the user ratings data frame that we can then iterate through and print out the results, mapping the IDs to names as we go. Now we're going to predict our ratings for other movies. Now just to prevent any spurious results, I'm going to restrict that analysis to movies that were rated more than 100 times. So things where we have a reasonable amount of data on what people rated them and the things that they rated them with. So to do that, I'm going to make a new ratings counts data frame by grouping the ratings by movie ID, counting them up. So now I have an RDD of every movie ID, the number of times that movie ID was rated, and I'm going to filter that. See, I'm kind of like chaining things together here so that only movies that have a count greater than 100 survive into the final ratings counts data frame. So at this point, I have a data frame that contains movie IDs, the number of times that movie was rated, and it only contains movies that were rated more than 100 times. And now what I'm going to do is create a test data frame that I'm going to send to my ALS model. So what I need to give ALS, our recommendation model, is a data frame of all the movie IDs that I want to recommend for every given user. So I'm going to create a new data frame that contains 2 columns, movie IDs, all the unique movie IDs that have more than 100 ratings, selected from my rating counts data frame. And I'm adding a new column called user ID that just contains the value 0 all the time. So what this is saying is that I want to go through every movie that had more than 100 ratings and predict the rating that user ID 0 would have had for that movie. Okay? And if I wanted to predict values for more than one user, I could just keep adding, more user IDs basically, right? So we then pass that data frame into our model. We say model.transform popular movies. That's telling it, I want you to predict ratings for these movie ID and user ID pairs, and that will come back as recommendations. And to get the top 20 recommendations for this user, I can just sort that by the predicted rating. So that's what I'm doing here. I'm saying take the final list of predicted ratings for user ID 0, sort them by the predicted rating in descending order, so the best ones are at the top, and take the top 20. And at that point, I have my final results. All I have to do is iterate through them and print them out. So let's see if it works. You can just watch if you want. If you do want to follow along, though, make sure that you make those same changes to your u.data file that I did and upload those into HDFS using Ambari under the user MariaDev ML-100K folder on HDFS. A little bit of extra practice for you there using HDFS if you're so inclined. So if you do want to follow along, copy those 3 lines into your u.data file and upload them into HDFS on your little pseudo cluster. So hit pause if you need to do that. But moving on, let's go ahead and I've already done that on mine. So let's go ahead and open up a session. And from the previous lectures, you should already have the script that we need here. That's the movie recommendations als.py script. You can go ahead and take a quick look at it, and yes, that is indeed the same script we were looking at. And let's go ahead and run it. Spark-submit. Movie recommendations als.py, just like that. Kick it off. You'll be surprised at how quick this goes. Oh, I forgot something. Remember, we need to set Spark major version to Spark 2. Since I'm using Spark session objects, I can't use Spark 1 with that, and it called me on that. So first we need to do this. Export Spark major version equals 2, just like that. And now, I like showing you when things go wrong, because, things go wrong in the real world. Let's run it again. Now we're cooking. Again, we can ignore these warnings about Hive context because we're not actually using Hive. So relax, Spark. It's okay. Now we're asking it to do some pretty heavy-duty stuff here, aren't we? Predict recommendations for 100,000 movies potentially, but it's gonna happen pretty darn quickly. Look, we're done. Oh, that's awesome. So let's look at the results here. So we are just echoing back the ratings that we plugged in for our fictitious user ID 0. Again, he loved Star Wars and The Empire Strikes Back, hated Gone with the Wind, and this is what it came back with. Now there is sort of a random element to ALS recommendations, so your results might not be exactly the same, but you can see they're pretty reasonable. So Star Wars, the original, came up pretty high. Well, obviously we didn't filter out movies that we already rated, so an exercise for the reader would be to do that. But some of these others are pretty good recommendations. The Fifth Element, also a good sci-fi movie. Monty Python and the Holy Grail, Close Shave. These are both sort of like irreverent English comedies. And, well, speaking as a science fiction nerd myself, I can say those also appeal to me as well. So I think there's some truth to that. Empire Strikes Back, of course, showed up again. Blade Runner, sci-fi, science fiction. Return of the Jedi, a movie that we didn't explicitly rate, but obviously a good recommendation, given that I like Star Wars and Empire Strikes Back. Some of these are a little bit questionable, but who knows? Maybe I would actually like Jackie Chan's First Strike if I went and watched it. Terminator, Alien, these all make a lot of sense. Mystery Science Theater. Love Mystery Science. Love me some Mystery Science Theater. Big fan of that too. Cool. So, we got some reasonable results here out of ALS. And there you have it, an example of doing something pretty complicated using Spark, and a great example of using the libraries built on top of Spark to perform complex analysis with just a few lines of code across an entire cluster on massive databases. So there you have it. MLLib recommendations using Spark, kind of showing you the full power of what Spark can do. Cool stuff.